Okay, so this question involves SN2 reactions. And when can't you do an SN2 reaction? Well, an SN2 reaction you cannot do SN2 when the alpha carbon is too hindered. Because typically what happens, the E2 reaction takes over. So examples of an alpha carbon being too hindered. Well, obvious one is tertiary. Another example is when the beta carbon is neopentyl. That's too hindered. Other examples when you can't do SN2 reactions are when the alpha carbon is sp2 or sp hybridized. Now, there is a case that you'll learn about in Chem 345 in which you can do an SN2 reaction on an sp2 carbon, but that is a rarity. It's an outlier. For all intents and purposes, in this class, in Chem 343, if the alpha carbon is sp2, you're not going to be able to do an SN2 reaction on it. And then there's a specialized case because the problem is specifically asking for this as a nucleophile. In that case, you won't be able to do an SN2 reaction on this, even though the alpha carbon is methyl, the least hindered of all of them, is because this leaving group right here is a strong acid, and that takes the proton off, and suddenly you no longer have a good leaving group. So let's apply this to problem 5. We see that A and C, those molecules right there, the alpha carbon is sp2 hybridized. So we can rule those out. We see that D, the alpha carbon is tertiary. So we can rule that one out. Now what about B? Remember, that when a beta carbon hang on a second, let me erase that. No, didn't want to erase that. Okay, computer issues. Remember neopentyl? This is also neopentyl. Now, if I add a carbon, this one, neopentyl, it's too hindered for SN2. If I add a carbon, I'm making it only more hindered. Add another carbon, again, making it even more hindered, and you get that. that beta carbon is quaternary, making it 2 hindered for SN2. So the answer here is E, that none of these can react with SN2. If you try to do this reaction, with this, you wouldn't get the SN2 reaction. The major product would be E2.